Greetings everyone. Today we're going to discuss the third question which was asked by the LeetCode in its bi-weekly contest. I assume that you have read the question, so I will directly move to the solution. So we have to give the total number of ways to split the ranges into the two groups, and since the answer could be very large, so we have to give the total number of ways to split into the two groups in the modulo of 10 to the power 9 plus 7. So how we can approach this question? So the key observation is here. Suppose I say that we have four effective components, and what do we I mean by the effective components? Effective components with non-intersecting components. Let's say I have the four effective components. Let me give you let AB, CD, and EF. Let's say we have the four effective component, and I am telling you that the none of the component is intersecting with another one. So here I mean by effective components means those components which do not get intersected with any other component, right? So suppose we have here the three effective components. So if we have three effective components, then how many ways we can split into the two groups? The first way is what? The first way is that we will assign all the three number. We will assign all the three number in group 1 and none of the number in group 2. We will assign the 2 number in group 1 and the 1 number in group 2. We will assign the 1 number in group 1 then 2 number in group 2. I guess it will go longer. Let me take the smaller example, right? Suppose we have two effective component, right? Let's say G1 and G2. We have two effective component. Then in how many ways we can arrange these components? The first way is that we will give both the component. We will place both the component in group 1 and none of the component in group 2, or we will put the AB in the group 1 and CD in group 2, right? Or we will do what? We will put the CD in group 1 and AB in group 2, or and the last case is that we will put both the groups into the group 2 and none of the groups in group 1. So can we say that if we have the n effective component, then our answer will be what? 2 to the power n, or all the possible combination of the n, right? Because it's pretty much straightforward, and we can clearly say that if we have the n effective component, then our answer will be what? NC0 plus NC1 up to NCN, which is equal to what? 2 to the power n. So all the possible ways of selecting the n pairs, n elements, right? So what we have observed? We have observed here till now that if we have the n effective component, then our answer will be 2 to the power n, right? So the questions boil down to what? Now we have to calculate just the effective components, right? So how we can identify the effective components? Let's say I have provided an array which is having the pairs like AB, BC, DE, and EF. So how many effective components are here? We can clearly see that here the two effective components are there. Why? Because this one and this one having the overlapping, right? And this one and this one having the overlapping, so it will be DNF. So yeah, so here we have the two effective component. Let's see this with the help of sample test cases, right? Here we have given the 5 and 15, and then we have given the 6 and 10. I am writing this number in the sorted order. Why I am writing this numbers are in sorted order? Because if we have written the number in the sorted order, then we can easily compare whether the first number of my ith indexing, if it is greater than the last element, if it is smaller than the last element of the I minus 1th indexing, it means what? It means these are overlapping and these two are not two different components, but they are effectively a single component. And what is the starting and the ending value of this effective component? The starting value of this effective component is minimum of 5 and 6, which is 5, and ending is what? The maximum of 15 and 10, which is 15. But here we are only concerned with the ending value, right? Why we are concerned with the ending value? Let's see the another sample test case here, right? Now here I will also write the numbers in the sorted order. So first it will the 1 3, right? Then it will be 2 5, then it will be 4 8, and then it will be 10 and 20, right? So I will start from here. I will check whether this number is smaller than the ending indexing of my previous one. Yes, it is smaller. This mean was that 1 3 and 2 4 are effectively a single component. So yeah, it is a single component. The starting value is this. And what is the ending value of this effective component? That the maximum of 3 and 5. So 5. Now I will come here. I will move to the next pair, and now it will again check whether the starting value of my current pair is smaller than the ending value of my previous pair. And what is the previous pair? Now here the previous pair is what? The effective pair is 1 comma 5. So previous pair will be what? 1 comma 5, and it is whether it is smaller than the ending of the 1 comma 5. Yes, it is smaller than the ending of 1 comma 5, means there is a overlapping, and effective pair will become what? It will become the whatever the starting value. We are not concerned the starting value, because main we are comparing the ending value of previous component with the starting value of the current component, right? So again we are not concerned with the starting value. We are, let's say the starting value is A. What is the ending value of this? Now the effective component, the ending value of the effective component, the maximum of 5 and 8, it is 8. Now I will move to 10 comma 20. Then we will compare whether the I is smaller than 8. No, it is not smaller than 8. It means what? It is a separate component, right? So we have to increase the count of the number of components. So earlier it was 1. So now it, after this, the count of the total number of components is 2. Now if we know the total number of effective component, our answer will be what? 2 to the power total number of count, right? So this was all about the solution. Let me walk you through the code for the better understanding. I have declared the initially the count as 1, because no matter what is the configuration of numbers are there, whether it is overlapping or not, there will be at least one component, one effective component, right? So I have initialized the count is equal to 1, and n will store the size of the range array, right? I have shorted the range to calculate the number of effective components. I have run this loop from I, starting from the I is equal to 1 till n, right? And I have compared what? I have compared is the starting value of my current component, whether it is the smaller than or equal to the ending value of the my previous component. If this is the case, this means what? My current pair and the previous pair was not two different components, but it is the same component. So I will merge these two components, and I will assign the ending value of my current component as the maxima of the ending value of previous and the current one. Why so? What I am done basically, I have done BC and CD, and if these two are having the overlapping, so the effective component will become what? The effective component will become the min of A comma C and the max of B comma D, right? So now in future, and if there is a F comma G, so we have to compare the F comma G with not with this component individually, but the effective component one. So basically what? We will compare the F will with what? The maximum of B and D. So I have just assigned this value to this value, the ending of my current value, if it is overlapping case, right? So that was all it doing in this code. And if it is not overlapping one, it means what? We have discovered the new component, and just we have increased the count of my component, and once we have the total count of the component, then answer is what? 2 to the power count. Then I have just calculated a 2 to the power count. And how we will calculate the power? I have used this code to calculate the power. What it basically does, that in each iteration we will increase the power of x by 2 and decrease the power of y by half, right? So let's just see how it is working. Let's say 2 to the power 3. So what it's doing here, whether my 3 is greater than 0, yes it is greater than 0. Whether this my value is odd, yes it is odd. So what it's basically doing, my current answer is equal to 1. So it will do 1 into 2, right? So 2, and it will decrease the value of y. So y will become what? 3 by 2, 1, and my and x will be equal to what? It will be equal 2 into 2, which is equal to 4. Now my x is equal to 1. Yes, again it is odd. Then my answer will be what? Answer will be my previous answer, which was 2, and the current value of x, which is equal to what? 4. So it is 8 right now, and again it will decrease the value of y. Then y will become what? Y by 2, it will become 0. And as soon as it becomes the 0, then the loop will end and we will get the answer. So it is a simple code to calculate the power of a number. If you have any doubt in this code, then you can refer to GFG or any other website to see how we can calculate the power a, how we can calculate the a to the power y modulo m. It is the code of that one, right? So this was all about the solution. The main takeaway here was that we have to just calculate the total number of effective components are there. Once we have the count of total number of component, then the answer is just 2 to the power count, right? And we cannot just directly generate the 2 to the power count because it will generate the overflow. So what we have to do, we have to do the 2 to the power count modulo m, right? And the way to calculate the a to the power b modulo m is here, that we will here. And yeah, this was all about the solution. Hope you understand the approach and the main takeaway. And if you have any doubt, then feel free to ask in the comment section. Thank you and have a nice coding journey.